So without any further ado, please help me welcome Tony Gentilcore.
Yeah, once again, like Steve said, my name is Tony Gentilcore. I'm a software engineer at Google working in web search infrastructure. You've also seen one of my 20% projects launch recently, the page speed extension. So I'm real proud of that. Hope you're getting some use out of it. Let me first start, before I even start talking about this, saying how humbled I am to be invited to speak here. My favorite part about Velocity is just the quality of the experts that are here. There's so many amazing people that are really fun to meet and talk to, and so I'm just humbled to be here. So round of applause for Steve and Velocity for setting this up, getting so many great people here. So how are we looking as far as presentation goes? This is yeah, so you can see I'm using the Beta Chrome on Mac, so we'll see if that treats me okay during this presentation. So this is the boring slide. Quick review. Why do we gzip? I can't see real well in the audience, but first of all, raise your hand if you're a web developer, or you're responsible for a website in some way. Maybe you're an admin or an ops. So a good portion of the audience here. Now, raise your hand if anyone, hopefully none of you raise your hand here, and even if you haven't, maybe you're not honest enough or bold enough to raise your hand, but is anyone not sending compressed responses from their web server? Or know that you're not doing that? That's awesome. I would love to see that everywhere. So hopefully there's no slide like this at Velocity next year. But for some reason, there's still a few websites out there that aren't, notably some large news websites that are not gzipping anything coming from their website. So why do we do that? Well, when you gzip responses coming from your web server, you save about 70% on typical HTML documents. And then I was wondering, what does that actually mean in terms of speed? So I ran kind of a point sample here. This is in a latency lab environment. It's not real scientific. But I took Alexa's top 10 websites, loaded them 100 times each in IE7 on Windows XP, and I did it both over DSL and dial-up to see how much slower it was when you don't have gzip enabled. So basically, enabling gzip for these websites sped up by about 50% over DSL, about 60% over dial-up. So this is really important to do. This is one of the most important things that you can do on your website, and it's so easy to implement. So basically, most of you, I've probably talked about this long enough. By this point, you're thinking, thanks, we all did that 8 years ago. Can we go now? But that's not quite the whole story. So like Steve alluded to, there's actually an issue here. Roughly 15% of users, although you've enabled compression on your web server, are actually not getting compressed responses. So why is that? That was surprising to me. Everyone I talked to seems to be surprised by that, and I don't see a lot of people bringing focus to this issue, which is why I wanted to talk to you about it at Velocity Conference. So first of all, you might think, is this bots or these scripts that just didn't implement it? No, not including bots. Are these old browsers? So all browsers since roughly the 4X version have supported compression, with a few exceptions like IE5 and compressed CSS don't get along well, and a couple other small exceptions like that. But is this old browsers? No, not really. We see something like 0.1% of Netscape 4X and 0.1% of IE under 4. So we have far less than 1% of really old browsers that don't support compression. So basically, if all the browsers hitting your site support compression and your web server supports compression, then what's the problem? What's getting in the way? Well, in order to look at what might be going wrong, it helps to know how compression works. So most of you probably know this. Like I mentioned, everyone here is an expert in their field in some way. But just a quick review. In the HTTP request, the browser indicates to the web server that it supports compression by sending an accept encoding header that has the encodings that it supports, so gzip and deflate in most browsers' cases. The server, when it sees that, then responds with content encoding gzip. And it's to mark that the response is compressed, and the browser should then unzip that. And so when I started looking at some requests, these are the things I started to see. A request with accept encoding but the I was X'd out, or the beginning was X'd out, or it was completely X'd out. So you can see that these X's and dashes and tildes are the same length as accept encoding gzip deflate, but completely obfuscated. So what could be doing that? Well, I started getting my hands on every license or demo version or trial version of various proxies and antivirus software and firewalls and things that are out there. And I found that there are basically two categories of programs that do things like this. There are client software, such as, you're probably familiar with things like Norton Internet Security or Zone Alarm that run on clients' machines. And then there's also programs like ISA 2006, which are very common in corporate environments, that are doing these things. So what do all these proxies and client software have in common? What they want to do is to view the response coming from the web server and either filter or modify that content in some way. And if the response is coming down compressed, they have the choice of either uncompressing that response, or a simpler way might be to strip the accept encoding header so that the server gets tricked and doesn't send it compressed, and then they can just examine that in plain text and probably save a little bit of CPU. But I think that saving the CPU at the expense of the much more expensive network bandwidth is the wrong trade-off to be made here. Obviously, that's the case. Otherwise, we wouldn't gzip on our web servers. It's also worth noting that unzipping is actually something like 4 times cheaper than zipping. So certainly, if we're willing to zip on our web servers, we should be willing to unzip when we're looking at that response. So at this point, you're probably thinking, great, thanks for telling me about this problem. A lot of my users are not getting gzipped and they're being slowed down unnecessarily, but that's client software, so there's nothing I can do. Well, I have 4 recommendations, and I can't get close to solving this problem. And that's part of the reason I wanted to bring some more attention to it, because I think that if people pay attention to this problem, that this software is likely to get improved. So that's actually my first point here is be a smart shopper. If you're an admin installing a firewall on a corporate network, or you're just a helpful son or daughter installing antivirus on your parents' computer, ask, does this software inhibit compression? And if so, consider using a different piece of software. And if you have older firewalls that are doing this, consider upgrading them to something new. You might be able to work out the cost structure such that you actually save money and bandwidth, even though you have a one-time upgrade cost. So the next thing that you can do as a web developer is to actually pay attention to the uncompressed size of your page. So this is another thing that I did here. I went through Alexa's top 10 websites, and these are all very well optimized and well-designed websites. And I said, what happens when I apply these techniques, which are pretty good at reducing the size of the uncompressed response, but don't do much to the compressed response? How much can I actually get it down? So first I applied JavaScript event delegation. Raise your hand if you're familiar with event delegation. Only a couple of people. OK, that's surprising. I recommend Googling event delegation if you're a web developer, because this is actually a very important technique for speeding up your website for other reasons. Having lots of event handlers on every element can slow down the responsiveness of your app quite a bit. So it's important to do for other reasons. But basically what event delegation is instead of, if you have a parent element that has a lot of sub-elements, instead of having an event handler on each one, you have one on the parent, and then you have one handler that handles that event, and it can tell based on the event, the object that's passed to that event, which element was actually clicked. So it makes your page smaller and faster. So when I did that, it saved about 5%. Stripping white space quotes, that's self-explanatory. Relativizing URLs, getting rid of the HTTP, getting rid of the fully qualified URL. Avoiding inline styling, so not doing style equals on every element, but pulling that up to CSS. aliasing JavaScript names, this is really important, but I wasn't able to test this because it's too difficult to hack up a page to test this sort of thing. But basically that means instead of writing document.getElement by ID a whole bunch of times over and over again, you alias that one time to a shorter name, and then you can just call that shorter name throughout your code. So I did all these things that I could think of to make the uncompressed size as small as possible, but I was still only able to reduce the page size by about 12% on average. Not quite gzip's 70% reduction. So this is a good thing to do, but it's not going to be a cure. Another thing you can consider doing, and I'm hoping somebody is bold enough to do this, is to educate users. On Gmail, if you visit it with Firebug enabled, you'll get this helpful little message, Firebug is known to make Gmail slow, fix this, hide. I would love if somebody looked at a stripped accept encoding header and said, oh, look, it looks like an intermediary got in the way and has messed up compression for this users, and gives them a link to a helpful article about software that does this and how they can fix that. Clearly not for everyone, but it would be awesome to start to see sites that can do these sorts of things, bring some attention to it. This last point that I'll make too is definitely not for everyone. So this is guerrilla warfare. This is, can we directly detect whether the browser supports compression or not? And a lot of people, when I first introduced this, look kind of like this cat here. It should probably say HTTP can't do that, but it's a cat, so we'll forgive him. So what do we actually have here? We have a web server that's completely capable of supporting compression, and we have a web browser that's completely capable of supporting compression. And the only thing that has changed in this whole flow is that in the request, something has gotten in the way and stripped the accept encoding header. So we say that's not reliable we can't rely on that anymore, so what can we do instead? Well, if that accept encoding header is missing, you can consider having a hidden iframe on the bottom of your page that loads after the rest of your page is loaded. It's kind of out of the way. This iframe is not cacheable, and it's always served compressed. And when it loads, it has a bit of JavaScript to set a session cookie that says, yes, compression actually works for this client. So we have actually verified by the fact that this iframe got downloaded and loaded, and we know that it ran and it rendered properly, and we can set this session live cookie that says, for this session at least, I don't know if this is a laptop that is moving around and maybe it works here but not there, but at least for this session, I've verified that compression actually works. So when you see this cookie on the remainder of that session, then you can just go ahead and send subsequent pages compressed. This is a violation of the HTTP spec, so it is guerrilla warfare. It is not for everyone. So be careful with this. You can't risk a single false positive, and test and measure. So like I said, I have 4 techniques here. None of them are a great cure, a total solution. You might be able to get some benefit from each. So what do I really want you to take away from this? Well, first of all, just don't assume that everyone is getting compressed responses. Measure this number for your site. This varies greatly by geography and by ISP and by operating system and almost any factor you can consider. This varies. So you definitely want to see, based on the demographics of your site, how badly is this affecting your site. For some sites, it may not be that big of an issue. For other sites, you might find that we've already done everything else. We've already spreaded our images. We've done everything. We're scraping against the wall of performance. We don't know what else to do. Well, here's another place where you've got a large chunk of your users that are being slowed down unnecessarily, and maybe you can do something about it. So if it's a major pain point for your site, do something about it. Thank you for having me here. There's a lot more details in this in Steve Sauter's new book, Even Faster Websites. So if you're curious, you can read there. As I learn more about this and talk to more people about this and find, hopefully, some better solutions, I'll be sure to share those as well. So definitely give me any feedback if you have information about that. How am I doing on time here? Is it 1 or 2 questions? Okay, excellent.